3, 2, 1. Hi everyone, and welcome to the sections 2.2 and 2.5 worksheet. So this is our first sheet of many, and basically how this is going to work is I'm going to go through the sections for each sheet, and what I've done is I've picked out parts of the textbook, mainly definitions, some interesting examples, just places where I want to talk through things a little bit deeper. And part of this is just to kind of give you extra explanations. The other part of this, the way you should be thinking about it, is this is how I can go through a textbook, especially a math science textbook, and try to read it. So whenever I'm going through something like a definition, what you should be trying to do is going to the book and seeing if you can model, and it doesn't have to be exactly like I do it, but model that type of reading, that type of critically thinking about what you're reading, not just kind of doing our skim reading. So that's what we'll do for the first part. You'll see me go through this just to kind of quickly scan this document, and then we'll do some examples. So we'll try to illustrate some of the definitions, important theorems through examples here. You'll see code here, output from code here that comes from Mathematica, which I will have Mathematica up for some of these documents showing you what I'm plugging in, especially if I want to change something around so we can get a slightly different picture. We'll look at the code as well. Just as a heads up, tables, I'm mostly going to give you the code for this, maybe change things here or there because they're a little rough to do in Mathematica. But in any case, sometimes we'll see it. And then, so we'll just go through some more examples, and then some exercises here, which I'm going to be doing these in the videos, but I highly, highly recommend, and this is true for these exercises and these other examples up here, right? Try them first, okay? Stop the video if you're going through them. Think about them. Try them. Even if you're looking at it like and you think I can't solve this, that's okay. Write down what you know about it. When you read this first sentence after we go through the above, after you've read some of the book, just see what you can write down. What are your initial thoughts about what is written here? Just anything that's happening in your brain, throw it down on the paper. And if you're having trouble with that, try verbalizing it. Talk out loud. Maybe you live with other people. Maybe they'll think you're weird. Who cares? Being weird's great. Just talk out loud what is coming into your brain. Don't even try to process it or think through it. Just spit out what you are thinking when you read each part of this sentence, and try writing that down after you've done it. And then see, after you've done that, if you can kind of put some more of this together, going back to the examples above, going back to the book, going back to what the video said, right? So just don't be afraid to try in this class, no matter where you're at in terms of you've been working on some section for a long time, you're just starting it, just try. We're going to not get things right constantly. All that matters is we keep trying, keep trying. So you'll see that down here, just more examples that I'll go through, but again, you should try them on your own as well. And then, so what you'll get here is you'll also get this document with just blank, so you can try stuff on your own, and then you'll also see a posted, I'll call it the solutions, but it's just the completed with notes where everything will be worked out here. Okay, so that's what these will all look like. You know, this plus the book are your main resources for the course. Of course, emailing, coming into office hours, talking to me is also very important, but this is kind of your main one of your main things to use. So let's get started. I won't take 5 minutes for every video to kind of start off. This was just the first one. So we are kind of going to put sections 2.2 and 2.5 and lump them together for this first piece because they both deal with this idea of limits. So from the textbook, and again, you should be reading through this section, I'm just pulling out some specific things. From the textbook, we have this definition. It says we write, and then we have some fancy notation here. The limit of f of x as x approaches a is equal to L. So I'm pointing to each piece as I read it, and you can see that sentence here I just read. The limit of f of x. So I'm doing this thing called the limit. What is that? What do I need to be able to do a limit? I need a function, which we'll write here, and I also need a specific value to be trying to approach, and that's a here. A is going to look like a bunch of different stuff. We could approach the number 1, -10, a half, pi. Later you'll see we can approach infinity. So it's just, you should think like a direction. Just tell me where to be going. That's what this is doing. This is the function I want to try to follow. And then over here, if the limit exists, we can write equals L. And L, again, will be a number. Sometimes we'll write infinity. And that's something we're going to have to talk about a little bit later in this document, because that's not actually a number. But symbolically, we all will know what that means when we write equals infinity. But if there is a limit, if it does exist, doesn't have to, we'll follow a function as x approaches a. So we're always doing a horizontal look. We're looking on the horizontal for a. Get close to a. Then we'll say, okay, where's the function going as I do that? And if it approaches an actual number, we'll write that number here, equals L. Okay? So here there is a kind of definition, not really here. The more technical definition is in the appendix. It's not something I'm going to test you on, so you don't need to look at it. If you're interested, you can check it out, and I'm happy to talk to you about it. But the kind of pseudo definition you can have in your head is we can get our function, our graph, our picture, which we'll show you one in just a second below. We can get that to be as close to L as we want by just taking our horizontal x value and getting it closer to a. So how close do you want your function to be to L? Well, I just need to get my x value that I'm plugging in closer to a. I can get closer and closer and closer to a, and that should be getting my function closer and closer and closer to L. And we'll see that below in a picture. Okay, so that's the idea of a limit. It's describing how a function is moving as my input. That's very important. As my input x is moving. So as I move my input closer to some number, what's the function doing? And if it's getting closer and closer to something like L, then we say the limit equals L. You'll see this notation here, and that's very similar notation. The function approaches L as the input approaches A. So very similar here. And there's one kind of big thing here that's important that is easy to kind of gloss over when you're going through this. And that's we don't actually care what happens at A. So what do I mean by that? Well, let me get a nice little drawing tool here. So when we're talking about limits, I use the word approaches, right? I use the word gets closer to, but I never said anything about x equals a. I never said this. Okay, I never said what happens when x equals a. We don't actually care, all right? We don't care what happens when x equals a. It's not something we care about. We just want to know what happens to the function as we get closer to a. Okay, that's very important. You do not need to care about this, x equals a. We do not need this. Okay, so we just care what happens as we get close to a. So important little side piece there to kind of keep in the back of your mind. We do not care about the actual point x equals a. So let's check out a couple examples and see what this actually looks like graphically. So let's go down here to this first example. Okay, so I've got this picture here. This blue curve is f of x, which is above. We have a rational function. These are always pretty good for trying to understand limits. Okay, and so the questions we can ask here are things like, what happens as x approaches -5? So I see this kind of weird thing happening here, right? If we go back to our pre-calculus days, many of us will remember that this was called an asymptote, a vertical asymptote. Sometimes you'll use VA for that, vertical asymptote. And so here's the interesting thing is that, you know, you're used to that. You look at it and you could say, okay, yeah, I see that there's a vertical asymptote there. Great. But we can try to explore that using limits. So the first question that we can explore here, we'll call this little a, is what happens to this function as x approaches -5? So, you know, what's going on here? Does the function seem to approach some y value? Remember, if we're thinking of this as x and y's here, this piece down here, let me do a little color coding here for fanciness. So down here, I'm always talking about the horizontal. Right here, I'm always talking about the horizontal. This value, on the other hand, this question mark here, this question mark, whoops, I didn't switch my colors. This question mark here is always talking about the vertical. Okay, so I know that that's a little tricky here. So I'm changing the horizontal. I'm trying to get towards this -5, and I'm going to follow my function. But what I care about is asking, what's the y value? What's the y value? What's the y value? What's the y value? What's the y? That's what I'm asking myself with this equals question mark. I'm saying, okay, as I go this way, what's the y value? What's the y value? Is it going somewhere specific? Can I follow it? Can I see kind of the pattern of what's happening? And so, you know, we can look through this. As I move this way, right, I'm going this way. Look, I'm going closer to -5 because this is just telling me to do it. Directions. Go towards -5. That's what this says. So I'm a good listener, so I'm going to do it. I'm right here. Okay, going toward -5. Now, what's the function doing? Okay, well, it's going down. It's going down. Okay, I'm still going towards -5. That's good. It's going down. It's going down. It's going down. And it just seems to go down forever. Right? If we kept following this, we could zoom out this picture, and it just seems to keep going down, 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 down forever. Okay, well, what about this side? So, okay, let's see here. I'm going towards -5. I'm going towards -5. I'm going towards -5. Okay, let's follow the function. It's going up. The y value, the y value, the y value. It's going up, 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 going up forever. So here's the question. As I approach -5, now there's two sides to do this from, right? This is important. This is something that, you know, we have to think a little bit about. There are two sides here to approach from when I'm trying to do this go to -5. I can approach from the right. So I approach from the right, or I approach from the left. Okay, so let's color that in a little bit here. So if I'm approaching from the left, that would be all of this. I'm going towards -5. I'm going towards -5. I'm going towards -5. It's because I'm on the left of -5, right? And I'm going this way. So I put my head at -20, and then I move it to the right, and I just follow the function. On the other hand, I could also come from the other direction. There's nothing wrong with that. I could come from the other direction. Let's see, what fun color do we want to use for this? How about dark blue? So to go from the right, I would put my head to the right of -5, and I would start looking this way. I'm going this way now. And I'm saying, okay, what's the function doing? That's from the right. All right? And here's the thing. In order for there to be a limit, these need to agree. So you go on the right. What's the function doing as I go to the -5? Oh, it's going down forever. Okay, well now go to the left. What happens to the function as I go to -5? This pink. Well, it's going up forever. Those don't agree. And so if you get that scenario, then the limit does not exist. So let's write this out. So for this scenario, the limit does not exist. So that's our shorthand. Does not exist. So DNE. So this limit does not exist because as I get to -5, the function is doing two different things. Okay? So a vertical asymptote, we can see kind of what's happening here. Okay? And then, you know, we could kind of play around with this and do a few other things, right? So let's try another point here. How about a limit that does exist? So let's try, how about the limit as x approaches 1 of our function? Okay, so let's get this picture and let's redo it down here. So we got a nice fresh picture here. So how do we get started with this? First things first, okay, pick out the x value that you're approaching. So right here, x approaches 1. So that would be, let's see, 5, 4, 3, 2, 1. Seems to be right here. That's my a. Okay, that's 1 that I'm trying to hit. All right, so then what we want to do now is ask the question, does this function, the y value, does this function, the y value, seem to get closer and closer to one specific number from both the left and the right? Well, just graphically, let's see what happens. I'm going to start over here. This is me. Hello. And I'm going to go from the left. I'm going to keep going until I get here. Now, remember, it doesn't actually matter what happens at this point, just what happens as I get closer to it. So I follow the curve, the y values, remember the y values. I follow the y values as I'm going this way, and it gets to this point. Don't actually know what that point is. We'll have to figure it out using the function. But it gets to here, right here, okay? So then go from the other side. All right, I'm going to start moving from the right. Here I am again. Transport it over here. Go this way. Walk this way. And I'm going to watch the y values, the y values, the y values. They're decreasing, decreasing to that point. And so it seems like from the left and the right, the y values are approaching the same point. From the left, it's actually going up to hit that point. From the right, it's going down. That's fine. That's okay. But they're both hitting that point. So it does seem like the limit exists. So this limit does seem to exist. And if we just kind of eyeball it, I know it's a little tough, it looks like, so let me write that out, this limit exists. And more specifically, it looks like the limit as x approaches 1 of my function is 1. Right? That's 2 halfway, it looks like about, is 1. Because it looks from the left and the right as I'm moving and moving closer and closer and closer to x equals 1. As I get closer on the x, remember, as I get closer here on the x, it looks like my function is getting closer both directions to 1. But that's a y value 1 I'm talking about. So be a little careful there. Okay, so that's graphically looking at it. Well, let's check this out using a table of values and see if we can use that to confirm. So, going down here, give myself some better space there. Forget about the 5 for a second. We're just going to focus on these two tables. Okay, so from the right side, I'm approaching 1. Let's think about these numbers here. It's always good to think about the numbers because you guys have calculators. You can do some of this in your calculators. I'm at 1.1. That's not quite 1. I'm a little bit away. 1.01. I'm getting closer to 1. So this is important. As I go down this table, I'm getting closer to x equals 1. So I'm approaching 1. Look at the values. These are the y values. A little bit bigger than 1. Ooh, closer to 1, closer to 1, closer to 1. At this point, the computer can't even tell that we're different from 1. We're so close. We're not actually at 1 yet. This is a little deceiving because the computer's rounding, but it looks, using the table, numerically, like we are actually approaching 1. Okay, and so just remember, input, these are the x values. Output, these are the y values. This is what we're actually trying to look at to figure out the value of our limit. From the left side, 0.9. Okay, that's pretty close to 1. It's on the left, it's less than 0.99. Oh, I'm closer, closer, closer. Again, as I go down this table, what am I doing? I'm getting closer to x equals 1. And what's happening with this y value? Well, look at that. As I'm getting closer to 1, it's getting closer to 1. So, what do we have here? We have from the right, our function is getting closer to 1. From the left, our function's getting closer to 1. That tells us the limit exists and equals 1. So I'm going to write this out in terms of some terminology. Okay, so the terminology for this, the way we can write this, these sides we're talking about, right? I keep saying right, left side. There should be some math terminology here, and there is. So this from the right side, we'd write this way. The limit as x approaches 1, and then do a little color coding here. Get used to it because I'm a color coding fiend. Plus. So see this word right? That's the plus sign here. That tells me I'm coming from the right. Okay? So the limit as x approaches 1 from the right of my function is 1. Okay, now down here, the limit as x approaches 1, now from the left side, I'm going to use something different for that. That's a minus sign. That's the word left, minus. So you see that minus, that means I'm specifically trying to talk to you about coming from the left side. Okay? So if the limit from the right is 1, the limit from the left is 1, these combine to tell you that the limit as I approach 1 of this function is 1. I got it from the right, got it from the left. I'm good to go. So our limit exists and equals 1. That's using tables. Up here, it was using the graph to do it. So from here, quickly we can see that the tables agree with our assessment above about that point -5, that asymptote. As I come from the right, it seems like we're getting smaller and smaller and smaller. As I come from the left, we're getting bigger and bigger and bigger. And so that's telling me it's different, that the limit doesn't exist. They're doing two opposite things. So using that new notation we just started talking about, let's just write that out again. The limit as x approaches -5 of our function, and here's the way we can write this to describe that, you know, it's not an actual number we're going towards, but we can still describe what's happening. We're going towards -infinity. Now let me draw in my little plus because I'm from the right here. And then we've got the limit as x approaches -5 from the left is actually infinity because I'm going up, 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 up. Again, these are not numbers. It's a way to describe kind of what's happening here, what the pattern is. And we put that little minus sign in the top for left. Okay, so graphically using a table, and then verbally, you know, we can use, you know, we can write this out using the definitions here. I'm just expressing it verbally, but you can also use words to describe that as well. So there we go, got some examples. okay? And then what we can do is, and this is where, we actually just did a little 2.5, but this is also where kind of 2.5 comes in, is we can also explore the long-run behavior of this function. Okay, so looking at this graph now, we want to have some idea of what the long-run behavior is. And so we have to remember this, again from pre-calc, long-run behavior. What does that mean? That's not too bad. That just means what happens to this function, so long run, as my input x goes to infinity and negative infinity. That's the question. What's happening to these functions, f of x, as I just go forever in either direction? Okay, and so graphically, it's a little bit hard to tell, but I see a horizontal asymptote here, right? And it's a little tough to tell exactly where, but if you try drawing it out, I think it's not too terrible to see here that maybe if I go to 2 and I draw a dotted line here, it looks kind of like I never hit that line. I'm getting closer to it, but I never quite hit it. This looks like it could be a horizontal asymptote, which would be our long-run behavior. Now, what's our trick way of doing this that you might have learned in pre-calc? Well, let's go back up to the actual function. Our trick way of doing this is if we have a rational function, two polynomials, one on top, one on bottom. Remember, the trick way was we could just focus here, and if we just take the highest power top and bottom, right, so that's 2x squared over x squared, these cancel, and I'm left with 2. So, pre-calc trick way says 2. Looking down here at the graph, seems to say 2. Let's write that out in terms of our actual notation though, right? The limit as x approaches infinity of f of x seems to look like 2. We've got some evidence. And as I approach negative infinity, go all the way left, 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 it seems to also approach 2. What about a table? Use a table. Use all your tools. So we go down here to the tables. Let's bring these up a little bit. Left tail means we're going left, right? Negative 10, negative 100, negative 1,000. I'm getting bigger, bigger, bigger to the left. What's happening to my outputs? Well, look at that. 3.2. 2 and some change. 2 and a little bit less change. Even closer to 2. Even closer to 2. So this seems to be going to 2 as the input goes to negative infinity. Okay, x and y. What about the right tail? Well, as this again now seems to go to infinity, this one seems to be approaching 2. Well, there we go. Okay. So, table says it. Graph seems to say it. And then our trick, let's go back up here, also seems to say it. So, we've got another type of limit we can do. Okay, so let's kind of just review what limits we've seen so far. We can approach a specific number here, right? Like -5 or 1. We can also approach infinity. Positive infinity, negative infinity. We can approach from a direction. We can approach one from the right or from the left and compare and see if those are equal. So, there's not too much to this, but also kind of a lot of stuff to it. But really, you just need to keep the one idea in your head, which is this down here is telling me where to go on the x, the horizontal. This limit piece is telling me, okay, once you're on that path, go towards infinity. Okay, I'm going to go towards infinity on the x. I'm going. This limit and the function are now telling you, pay attention to the y values. Is there a pattern? Does it seem to be doing something that you can kind of predict where it's going? That would be this number here. Or, in some cases, we could write infinity. if that's where it's going, just getting bigger, 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 bigger. Or, again, in the scenario where it's doing different things, we can say it does not exist, which is another option. All right, so there you go. That's the limits that we'll be talking about, and we are going to learn a few different ways to actually calculate them, not just relying on a picture, a table. We can always use that as backup, which is awesome. But we'll also learn some techniques to do it algebraically that will just make our life a little simpler. So, number one, again, try this on your own before you continue. Okay, you tried it. Explain in your own words what is meant by the equation the limit as x approaches 2 of f of x equals 5. Is it possible for this statement to be true and yet f of 2 equals 3? So when I read this equation here, what it tells me is as I approach x equals 2 from the right and left. So that's one of the key things. We've got to go from both sides here. The function f of x, and again, these are the y values, right? So be careful, it's the y values specifically. So the function f of x approaches, and I'm going to even write that in here, y equals 5. It's very important. The first piece is horizontal. Where do you go? Then you look at the function and say, okay, well, what's the y value here, that vertical? What's happening there? It's going towards 5. All right, so that's part one. Part two, is it possible for the statement to be true, f of 2 equals 3, and that above statement, the limit? Yes. So remember, what's that one little tricky thing I had said above? I'd said above, I don't care about x equals 2. Remember, I'm doing the limit as I approach 2. I don't care what happens at 2. It does not matter for the limit. So we can have that the function equals 5 there, and the limit and the function agree. Awesome. We can also have that they don't, and that's perfectly fine, right? The limit does not require. Now, we will talk about when they do line up, and that's going to be important. But for now, we do not care. The limit does not require that as I go to 2 with this function, it equals plugging into. This is a much more special condition that we will explore, okay? But it does not need to be true here. It does not require that it equals the function at that value. The function could just not be defined. That's okay. The limit can still exist. The function can be a circle there. Unfilled in circle. That's our usual, which I'll show you in just a second. That's our usual way to do that. Totally fine. Okay, explain what it means to say the limit as x approaches 1 from the left, careful, from the left of f of x is 3, but from the right is 7. Okay, what does this mean? Right? So, what does it mean? This means that as I approach, so as I look, right? I'm looking, right? I'm looking as I approach x equals 1 from the left, f of x approaches the y value. On the other hand, right, on the other hand, as we, or I, approach x equals 1 from the right, that's the plus sign here, from the right, f of x actually goes up to 7. F of x approaches, this word here, remember, is very important, approaches y equals 7. Okay, in this situation, can we say the limit exists? No. We need the limit from the left and right to be equal. All right? We need those limits from the left and right to go to the same thing for the general limit to exist. If that's not true, then you don't have a limit there. All right. So what other kinds of questions could I ask? Well, a very common one you'll see a lot of practice, and you know, if you're trying to Google more examples or explanations or see videos, you'll see more examples of pictures like this. So it says, use the given graph of f to state the value of each quantity. There's 5 of these here. If it exists. If it does not, explain why. So, what's this one say? Well, this one says, so always start down here. As x approaches 1 from the left. So, here's what we'll do. We'll color code. Well, look at me again, going with the color coding. Here's 1. As I approach this from the left, what's the function doing? Well, let's follow it, right? The function, as I go here, it looks like it's approaching 2. Okay, from the left. All right, what about from the right? So, color code. The palette is not as colorful as I'd like. Not that many options, but that's okay. So as I approach now from the right, and I try to get to this point, well, now this function is actually going all the way up to 3 here, right? This is as I get closer to 1, I'm going up, 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 up to 3. So I put that down. The y value goes to 3. Okay, well, what about the limit as I approach 1? General limit as I approach 1 of this function. Well, from the left I said it was 2, from the right it was 3. These are not equal, so this does not exist. D and E. Okay? Let me actually do that in blue so you have it on the paper in blue. Does not exist. Why? The limit, because there's 2, from the left and right do not agree. They're not equal. All right, what about 5? Well, okay, so let's check out 5. So how do we just do a general limit graphically? Well, let's go, let's use pink. Oh, the function's in pink, darn. Just try gray. So here's 5. I'm going to go from the left. What's happening? 4. So let's think about this. The limit as x approaches 5 from the left of my function is 4. All right, what about from the right though? Well, let's check it out. Let's do that in black. How about as I go this way? Well, I watch my functions going down, down, down until 4. That's equal to the limit as x goes to 5 from the right. Hooray! So then this equals 4. The left limit is 4, the right limit's 4, the limit's 4. F of 5, undefined, aka does not exist. There's a hole. Hold. There you go. So, but that's okay. The limit does not care about what happens at that actual point. If there's a hole at the point, don't care. If the point is not where the limit is and it's somewhere else, don't care. Doesn't matter. All right, so there you go. Let's try one more. Same thing as the last one. So let's get into it. Go back to blue. All right, what happens at 0? Well, let's go to 0. 0's right here. As I go from the left, it looks like 3. As I go from the right, it looks like 3. So that's 3. That's it. Not too bad. This 0 is a nice point to go towards. Okay, how about as I approach 3? So this is now x is 3. It can be a little tricky. It can mess us up a little bit. We just got to keep focusing on this telling us where to look horizontal. So that's the 3. All right, as I go from the left, what happens to me? The function gets up to 4. As I go from the right, what happens? So, okay, I'm now to the right of 3. And I'm going up and I hit 2. So let's do that one. Again, that's this way. So is there then, all right, our question now is, do we actually have a limit at 3? Well, from the right it's 2. From the left it's 4. Those aren't equal, so does not exist. Right? Why does this not exist? The left and right limits do not agree. Okay, right? 2 and 4, not the same. Okay. What about f of 3? Well, I go to 3, I look, there's a dot, that's 3. Just a filled in dot at 3. Nothing too special there. All right, let's check out 5. For the function g whose graph is given, again, same thing. State all the stuff. So, first one, what happens as I approach 0 from the left? So let's look. Here's 0. I approach from the left, I get, looks like -1. So let's draw that in. Equals -1. From the right, what happens? So here again, 0. From the right, looks like I'm -2. And so these are different, so does not exist. Okay, I'm going to be a little lazy here and not do the explanation. Same explanation as above. They're not equal. Left and right are not equal. Okay, what about 2? As I go from the left, I'm up at 2. As I go from the right, I'm down at 0. And so this does not exist because these are not equal. G of 2, let's look, is 1. And there you go. Oh, forgot one. The limit as I approach 4. Well, let's see here. As I go from the left, I'm coming up and I'm hitting 3, looks like. As I come from the right, I'm going down, going to 3. Both sides go to 3, so this is 3. We've done it. So, bunch of examples of limits. We've done some infinity, we've done some exist, not exist, seen a couple different examples. So go through the book examples, check those out too. You've got the computer homework, you've got written homework. There will be a quiz on this, you can check the schedule for that. And then we will be having a test that will have this included, I believe. Well, I'm not going to say a time because you might be watching this the day before the test, so check the schedule for that. I almost did it, but I caught myself. So check the schedule for that as well. Make sure you ask me questions on any of these examples, any that you're going over on your own, anything at all, and we'll check it out together.